problem 50 from Neetcode 150. Same binary tree. So we are given the roots of two binary trees. The trees are respectively called P and Q. We have to return true if they are exactly the same tree. Otherwise, you have to return false. So I think that understanding the problem is quite straightforward. It's like, do you have the exact same thing twice? Did you do a Control C, Control V on the first tree, or did you modify the second one? Okay, so you can see that now. I don't even think I need to explain that each child have the same value, and they have the same structure, so they are the same. Here you can see that this is false because there is one 4 that has a left child with value 7, but the other one has a right child, not a left child, of value 7. Okay, so this is not the same structure, even though the values are quite the same at each level. The structure is fundamentally different. So let's go ahead and see how we can solve this problem. So we are going to use a recursion for this problem, and we are going to segment every single steps into another problem. So first we're going to take a look at the first value. Is the first node the same as the first node of the other three? In our case, we're lucky, and yes, it is. So we can keep going. And at this point, we actually don't even need to. We don't even need to look at the first value again. We can see that we now have. I'm just gonna add some layers. Let's say we have 1 and another 1, and same here. We have a 1 and we have another 1. Okay. Let's just say that this is not a 1. This is a 7. Okay. So once we reach that second layer, we are going to go for every single nodes at this point. So we're going to take a look at the 2, and we want to see if 2 is the same as the 2 here. So since it is actually right, we are going to keep moving forward on a deeper layer, and we're going to do this for 3 as well. Okay, so we're going to take the right child of both 3s, and we're going to compare them. And we are going to do the same thing after this for each child of each value. So see that at every layer, once we confirm that the values are the same and the structure is the same, we can sort of like cross them and just see if the child's tree is actually the same as the child's tree of the other one. And when I look at the other one, I see a 7 at the position where the other 3 is as a 1. So we can see that these are not the same. So we can now return false. Okay. So let's go ahead and actually write the code. But first of all, we have to make sure that if we have 2 none, right? So if we are given none twice, we are gonna have to return through, because technically 2 3s that are composed of none is is technically considered to be the same. Okay, so this is something you have to just keep in mind. We don't necessarily have to write it in the code. You will see. What we need though in our code is first to check if well, we are gonna write it first. Okay, so if we actually have 2 none, it either means that we receive basically 2 empty 3s, or the second possibility is that we reach the end of a branch in our 3, right? Because we are eventually going to reach a place where the tree no longer goes any deeper in there. So I mean, if we don't reach at this point, it means that we have an infinite tree. So we have to make sure that at the bottom of the 3, so if P and Q are none, so we are going to say basically if not P and not Q. All right, so if this condition is true, right, we are going to return. Pardon me. We are going to return true. All right. And after this, what are we doing if P and Q exist? Okay. So what if there's a P and there's a Q? First, there are many edges to take in consideration. Is it possible that P exists while Q does not, or vice versa? Is it possible that P and Q exist but they are not the same values. So we are actually going to put all these edge cases on the else statement after this, right? So we are going to say that else we return false. All right. So we don't have to actually care about these edges anymore, and we can really focus on what we want to do for recursive calls. If the value of p and the q is the same at this position, so if p.val is equal to p is equal to q.val, so this is where we want to start doing our recursive call. So we are going to return basically the same function where the elements will be the left child of the p3 and the left child of the q3. Okay, so we are going to return self that is same3, where initially we are going to have p dot left and q dot left, right? I hope this makes sense, because we want to compare the left side on or the left child on both threes, and we also want to compare the right child. So we are going to call this excuse me. So is we're going to say self is same3, where we are going to pass the values p dot right and q dot right. Okay, so that's going to handle the case for us. And basically if we go to the bottom of the three, we are going to return true, and by doing this we are going to move up the tree by passing her through every time. Otherwise we are going to return false somewhere in the tree, and this is going to basically set the output to false. So like in the example 3, we can see that initially we are going to return the else case, because p and q are not it in this case. Well, p on the left child is actually existing, while the p on the left child on the right child, sorry, it does not exist. Okay, so let's submit this code, and we have an error. Indentation, yes, for sure. Okay, let's try this again. And there you go. So I hope you're done in this video. This was problem 50 of Neetcode 150, and I hope to see you in the next one.